Hey everyone, welcome to another video of mine. Today we'll be going through some CSEC technical drawing multiple choice questions, and I'll be briefly explaining why the answer for each one is that answer. Okay, let's go.
It's caught in the crossfire. It's caught in the crossfire.
Alright, so the first question says, in an isometric sketch, circles and arcs will appear as segments, round, smooth lines, ellipses or path of ellipses, or round arcs without distortion. So everyone should know what a regular circle is. Here we have a regular circle in 2 dimensions, and an isometric circle or an isometric arc will look something like this. Okay, so it's not an exact 2-dimensional circle. So the answer would be, and these are ellipses. If you look here to your right, you will see that the 3 ellipses are shown in the cube. So these are isometric circles that looks like ellipses. Okay, so the answer would be an ellipse. All right, number 2 says, which of the following instruments is used to draw irregular curves? Okay, so you have your regular curve, which is your circles and so on. What is used to draw an irregular curve? Is it a compass, a protractor, a flexicurve, or a radius curve? And the answer would be these two, which are called flexicurves. Okay, they come in different sizes, so you can have a shorter one or you can have a longer flexicurve. Okay, so the answer would be flexicurve. Number 3, which of the following drawings show triangles of equal area between parallel lines? Okay, so you have these 4 options, and which one of the 4 shows triangles of equal area? So if you look at each one, if you look at the last 3, you'll realize that the base of the triangles are not the same. Okay, so the base of the triangles for this one, EF, is not the same length as HF. QR is not the same length as QN, and ST only have one base. So basically what you need to look at is the base of the triangle needs to be the same length, and no matter where the apex of both triangles are, when you add them up, the area would be the same. Okay, so the answer would be A. All right. Number 4 says, in the drawing above, which of the following letters indicate the center of the arc which is tangential to the 2 circles? So here you have the 2 circles right here. Which of the following would be the center of the arc? Is it M, is it N, is it O, or is it R? Well, M is actually in the center of this circle, so it cannot be the arc. N is the center of the larger circle, so it cannot be for the arc. O is actually the center of this arc, which is tangential to the 2 circles, as I said in the question. So the answer would be O, and R is basically the radius of that arc. Okay. All right. Number 5, which of the following views below show the plan of the object illustrated in the 2 views above? So the 2 views are a side view and a right view or a back view. And if you remember in the past videos, which I suggest you look at, you will see that you have 6 different views. You have the top view, back view, right view, bottom view, front view, and the rear view. So what we are looking for is the top view. If you look at this drawing, what would you see to the top looking down onto the drawing? And this is an example of it in 2D. And these are the options. So the first one over here, if you look at the drawing, you have a circle inside. So this needs to be represented by a hidden line, okay, or hidden lines. So this one, it can't be this one because it has no hidden lines. All it's showing is the object lines that are outside of the drawing. Basically, this corner, that corner, this corner, this corner, that one, and this one looking down onto the object, okay, looking from up down onto the object. It cannot be number 2 because you're only seeing one hidden line, and the outline for a circle on each end would need 2 hidden lines. It cannot be number 4 because the hidden line is in the wrong position, okay, it's on the outer part. It basically would be around here, okay, so it cannot be that. So it has to be number 3, because if we put it in line now, you can see the hidden lines, the 2 hidden lines are in line with the edges of the circle, and then you have 1, 2, which you would see looking down, this line and that line, which would be this and that, and then you have this corner, which would be here. So everything has to match up according to what you can see from the plan view or the top view, okay, so that would be the answer. All right, number 6, which of the following correctly defines the locus of a point? So the locus of a point is, if you don't know, is the path traced out by points as it moves, okay? So you have a number of points that are traced out, and that forms a line to form, let's say you're doing a circle or an ellipse. And this would be an example where you have different points traced out to form an ellipse. And it doesn't have to be an ellipse, it could be any shape. As long as you're tracing out different points, it comes from a locus, okay? All right. Which of the following circles is correctly dimensioned? Okay, so you have 4 different options here. Which one would you say looks like it's dimensioned properly? So let's start from the right. It cannot be this one because this is showing R, and R stands for radius. However, it is pointing towards the circumference of the circle, so it cannot be that one. This one, it's pointing to the circumference, but it's not specifying any measurement or anything or what it's talking about, so it cannot be that one. This one, it's showing a dimension line, so it's actually telling you the measurement from here to here, and it has nothing to do with the circle, so it cannot be that. However, this one shows the diameter symbol, and the dimension line is actually inside, which is showing you where the measurement is taken from. So it shows you the diameter, which is shown here, and it shows you the measurement, which is, or the dimension, which is shown here. Okay, so this would be your answer, which is the correct one. All right. Number 8, the polygon shown above is a regular hexagon of side, which means that you have to figure out which one of these sides, and a hexagon has 6 equal sides. Okay, if you know about polygons, you would know a hexagon has 6 equal sides. So it's asking what's the measurement basically for one of the sides. So you have this measurement as was shown in the previous drawing. This is the diameter of the circle around the hexagon, okay? Therefore, if you, and it has the easy answer, which I'm gonna give you, and you have the more maths centered answer. So basically, if you have the circumference right here and you know the diameter, you would know that half of the diameter would be the radius. So in a hexagon, once you know half of the diameter, which is half of 95 as shown here for this instance, you would know the length of the side. So half of the diameter is 95. Half of the diameter is 47.5 if you divide 95 into 2. So 47.5 would be the length of the side. Okay, now the more in-depth answer would be to use trigonometry. So basically, once you have the diameter, which is 95, and you found the radius, which is half of 95, um, all the lengths of the 6 areas, which is the hexagon, would also be 47.5, which is half of 95. So once you've found that and you have your diameter line, it would strike down half of the length of the side that you are trying to find. So what you have to do is find x and multiply it by 2. And to do that, you have to find one of the triangles that the diameter line is intersecting, and here you will find 30 degrees because each sector is 60 degrees, because you have a circle which is 360 degrees. If you divide it into 6, which is the hexagon, you will have 60 degrees for each piece of the pie basically. So once you split that piece into half, you will have 30 degrees. In trigonometry, you want to find the opposite, which would be this side, over the hypotenuse. Okay, and you want to use the sine option, and if you calculate 30 sine 30, you will get 0.5, and that would be equal to x over 47.5. So here you see sine 30 would be equal to x over 47.5, and in order to figure out x, you have to move 47.5 over on the other side, and once you calculate 47.5 times 0.5, you will get x. However, that's not all. You also need to multiply the answer times 2 in order to get the length of the side. So okay, so that's the more complicated answer. All right, so the answer would be 47.5. All right, number 9 says the triangle illustrated above can be constructed with the use of. Okay, so a ruler and a pencil would not give you the angle that you need right here. A compass and protractor would not give you anything to write with. So the answer would be a compass, a ruler, and a pencil. Okay, you don't necessarily need a protractor, because you can use the compass to do the same thing. Okay, all right. So number 10 says, which of the following is the view of a right triangular pyramid? Okay, so a right triangular pyramid is a pyramid which has a right angle at its base. So the base of anything is the floor of it, basically the bottom of it. So if you want to look for a right angle triangle, it cannot be this, because the base of this is a circle. The base of this is a 1, 2, 3, 4, 5, 6, a hexagon, and the base of this would be a 1, 2, also a hexagon. So this shows two sides, and if I show you it more, this would be the answer actually. And if I show you it, the base, which is shaded, would be a right angle triangle. Here you have a rectangular pyramid, and here you have a triangular pyramid where the base is a triangle. So this will be the answer. Okay, all right, thanks for watching this quick video. If you haven't subscribed to the channel, hit the like button, hit the bell notification for more, because another video will be coming soon. Okay, thanks for watching. Bye.